Alf Aquitaine Norge has had many years of experience as a field operator on the Norwegian continental shelf and as the developer of technologically advanced remotely controlled production systems, working above the sea's surface and deep under, down on the sea floor. The search for oil and gas presents tremendous challenges to all of those involved. The Heimdal field is a reservoir of rich gas containing a high proportion of natural gas liquids or condensates. It's located 35 kilometers south of the Frigg field and 180 kilometers west-northwest of Stavanger. It was discovered in Block 25-4 in 1972 during the drilling of the very first exploratory well. The next question was to find an economic means of bringing these products to a waiting market. In 1980, joint transportation with gas from Statfjord and Gullfaks offered a solution. The dry gas is transported in the pipeline from Kårstø to Ekofisk. Through this system, the Heimdal gas is brought to the European market. This would mean that the wet gas condensates would have to be extracted on the Heimdal platform. These could then be pumped through a smaller pipeline to the Bray field and on to Scotland. The platform will be tailor-made to the needs of the market and requirements of the reserve itself. In order to save precious time, the design will be based on a conventional concept. A steel jacket with a support frame carrying the necessary process and power modules, living quarters, flare boom, drilling facilities, and all the necessary ancillary equipment. The Heimdal platform will be the largest steel structure ever built in the Norwegian sector of the North Sea. Alf Aquitaine Norge and the partners in the Heimdal field prepare a detailed plan that describes all aspects of the proposed financing, construction and operation. This they present to the Storting, Norway's parliament, in February 1981. 3 months later, Norway's elected representatives approve it. Stavanger, where a Heimdal project team is established to see the development through. Time is of the essence. They must meet an agreement with Statpipe for the delivery of gas to West Germany by July 1986. There are scarcely 2 years in which to complete the engineering and onshore construction. The project management must set the necessary schedules. For the first time, a Norwegian company is awarded the contract for the design and engineering of the topside facilities, including all the treatment and production modules. Engineering has 6 months to work out the designs and specifications. The construction of the Heimdal platform is planned, ordered and coordinated from Stavanger. Work sites are found across Norway and much of Europe. Parts, services and materials come from as far away as Japan. All are supplied under competitive conditions of quality and price. Fredrikstad, Norway. The near Fredrikstad Mekaniska Verksted constructed both the main support frame with the cellar deck and the generation module, which is being slid out of the work hall prior to being completely outfitted. The project team supervises and coordinates details. Kongsberg, Norway. The gas turbine division of the Kongsberg Våpenfabrik is building 5 3-megawatt generators which will power the platform, using as fuel the gas from the Heimdal reservoir. The generators can function on different mixtures of wet or dry gas. Designers check details. Hamburg, West Germany, for many centuries a fishing and sailing ship harbour. In 1982, the construction site for the Heimdal living quarters, a module designed to accommodate 120 people. Bordeaux, France. At the Ponticelli construction yard, the large reflux column is being installed on the separation module. When Heimdal is in production, this tower will ensure that the condensate is produced to a stable quality. Ponticelli has had much experience building for the oil refining industry. Holland. Far up the Maas River at Gorinchem, in the centre of the Netherlands, Mercon Steel is completing both the drilling substructure and mud module. The Heimdal platform must be equipped to perform the full range of drilling and workover operations. Back in Stavanger, the project team of now several hundred people continues to coordinate the thousands of details and ensure that progress keeps to the schedules. Kristiansand, Norway. The wellhead module is being sea-fastened onto its barge. The Kristiansand Mekaniska Verksted has come to specialize in the building of drilling modules, and this marks the completion of another achievement in a high-technology field. Tønsberg, Norway's oldest city, where Heimdal's 90-meter flare boom and the drilling derrick seem strangely disproportionate in a 13th century harbour that's warmed by the July sun.
Donc j'avoue que j'étais pas compris, ils ont pas fait moi j'ai éventuellement quelques trucs dedans, mais les documents
Cherbourg, France. The giant Heimdal jacket, soon to be the largest steel jacket on the Norwegian continental shelf, is eased from its construction site onto a sea-going barge, slid slowly over a silicon lubricant. 18,500 tons constitute a heavy loadout, and great care is taken to ensure that it will go aboard during the high tide, whilst the barge is at the loading level. Soon it will be standing on the sea floor, 130 meters high. Of more than 20 offshore platform jackets built in Cherbourg, none has been bigger than Heimdal's. 1.5 years of planning and construction are marked as the jacket slips into the sea. The double-craned barge Hermod is ready to lift the floating jacket and ease it into place. But this is not necessary. From the jacket's control capsule, the upending proceeds as planned. Hermod need only make minor adjustments with her winches, positioning the jacket exactly over the mark on the seabed. That is, over the highest point of the Heimdal gas reserve. surface, the Heimdal jacket is standing upright. During the next 2 weeks, piles are driven into the sea floor, fastening it onto the seabed for years to come. It was within a record time when the module support frame started its tow out from Fredrikstad harbour to the Heimdal field, only 3 years after the initial approval from Norway's Storting. The module support frame is a tubular structure which will transfer the weight of all the topside elements to the jacket on the sea floor. The module support frame with its cellar deck weighs some 4,000 tons. Using the world's largest crane barge, Balder, specially reinforced for the job, its lift and setting was the biggest ever undertaken in the North Sea, if not in the world. The Heimdal jacket had been installed in July. The 1984 weather window with a calm sea holds. All is to be installed before the end of August. The module support frame and the 5 modules. The compression module, the separation module, the generation module, the mud module, the wellhead and the living quarters. The lifting and setting of modules has been a successful day and night operation. The living quarters is set at the west end of the platform, the furthest point from the wellheads, as far as possible from the drilling and production operations. Safety and security are part of an ever-present theme on offshore platforms. The drilling structure and the helideck will soon be in place. Within 2 weeks, the whole topsides are installed, a record time for such a huge undertaking, the end of which is marked by the setting in place of the drilling rig.
God morgen, Heimdal. Ja. Ja, litt øyeblikk.
The hookup phase, thought out and planned long in advance, now becomes real, challenging the experience, initiative and preparation of the Heimdal project team.
No, you don't know about the tagging of solenoid?
One of the first of these operations is to connect into the 36-inch stat pipe gas line, which has been laid up to Heimdal. During May 1985, the condensate pipeline between the Bray Field and Heimdal is set in place by the lay barge EPTM 1601. On board, the positioning and monitoring of the pipe laying operation requires round-the-clock attention to ensure that the pipe reaches the seabed in its correct configuration. Over 7,000 pipe sections to be cleaned at each end, welded, ground fine, welded again, polished, x-rayed and sealed over the joint. And then the barge is pulled forward by its own anchor winches nearer to Heimdal. Since September of '84, 400 workers have been living in shifts aboard the hotel rig Treasure Supporter, carrying out the hookup and commissioning of all the systems, connecting the modules into an integrated platform. It began with the cold hookup, pipes and electricity and air ducts that enable people to live on board. The comfortable living quality came later. Meanwhile, the process equipment was being joined together and the drilling facilities made ready. A Norwegian-built system uses digital control for the main functions of the platform. Drilling began in early spring 1985. There are 10 wells, with one used for re-injection as necessary. The drill bit goes down over 2 kilometers through compacted shales to the sandstone layers which hold the gas. For maximum safety, Heimdal is equipped with free-fall lifeboats and all offshore personnel are trained in their use. Norwegian offshore oil platforms are considered to be the world's safest and most comfortable. Perhaps this is because they're not considered a distant, remote workstation, but